Alright, in this video we're going to look at 6 sample questions that you may see on the DMA 60 portion of the placement test. And remember this too, DMA 60, even though there's DMA 70 and DMA 80 classes, if you pass or if you place out of the DMA 60 portion for your DMA placement test, you also automatically place out of DMA 70 and DMA 80. So keep that in mind. You have the potential to place out of 3 DMAs, or you have the potential to automatically place into 3 DMAs depending on whether you place in or out of DMA 60. Now DMA 60 covers polynomials and quadratics. We will do some graphical and algebraic representations of these, as well as some real-world problems. You'll add, subtract, multiply, and divide polynomials. You'll factor some polynomials, and then you'll solve some polynomial equations. Even though all these topics here will not be covered in these 6 examples, you can always visit this website to find all this material and more videos there. So let's go ahead and have a look at number 1. All the line segments in the figure above meet at right angles, and the lengths of 4 of the 6 sides are given. So we have t, y, z, and x. These 4 sides are given, but we're missing 2 right here. I don't know what that red dot is. Anyway, which of the following represents the area of the figure in terms of x, t, y, and z? I'll tell you what we're going to do here. Let's draw a line right down here. Now I'm going to do it this way, but you could have easily have done it across this way as well, or you could have done both of them. But what we're going to do here is we're breaking you can do any of these techniques that I'm showing you. But like I said, I'm going to go down here. And what I'm doing is I'm breaking this shape up into 2 rectangles, and if we can find the area of each rectangle separately, we can add these 2 together to get the area of the whole figure. Now before I jump into all these variables and whatnot, let's talk about these missing pieces. Suppose instead of z down here, suppose the length of this whole side was, say, I don't know, 10. And then suppose this t up here, instead of it being t, suppose this was 4. Now the reason why I'm doing this is because I want you to think about numbers. If the whole thing down here was 10, and this piece up here was 4, then this piece from here to here, just that little part right there, is also 4. Opposite sides are the same for a rectangle. That means this leftover piece over here would be 6, because 6 plus 4 would give us the whole 10. But really what we're doing here is we're taking this whole side, which is z, and if this is t, this is t right here, just like I said, 4 and 4, and then we had to subtract the 4 a while ago from the whole side to figure out this missing piece. With that in mind, we can say from here all the way to here, we can say it's going to be z minus t. And this will always work. Let me throw another example at you. Suppose instead of z, suppose this was, say, 15, and suppose t up here was, I don't know, 7. It doesn't really matter. If this is 7 from here to here, that means this is 7 from here to here, which means if we take 15 minus 7, that will give us what we have left over. 15 minus 7, that will be 8 right there, and as you can see, 8 and 7 gives us this whole 15. But regardless, every time what I'm really doing is I'm taking this z, which is the whole thing, I'm subtracting off whatever t is to figure out what we have left right here. So that's our algebraic approach to that. Now let's figure out this missing piece here. Do we really need it? Not necessarily, and you'll see why in a second. So with this in mind, let's find the area of this rectangle right here. The area of a rectangle is length times width, and what you want to be careful with here is this. The length is not z. I'm only talking about this rectangle right. I know that's sloppy, but I'm talking about that rectangle right there. So the length would be z minus t. The width would be x. Maybe you've heard of the formula base times height. It's the same thing as that, I just called it length and width. So that's the area of that rectangle. Now, what about the area of this rectangle? Well, let's do length and width, or base times height. We would multiply y, that's that whole side here, which is the same as this over here. So we got y times t. So these are the areas of the 2 separate rectangles. And we want to add these 2 areas together. Once we find this area and this area, when we add these together, we get the area of the whole figure. So a little bit of algebra here. we have to distribute this x to both of them. I know it looks like I'm distributing backwards, but it works the same as if I had an x in front. So x times z is xz. X times a negative t is going to be negative tx. It doesn't matter what order you put these letters in. Tx, xt, same difference. And then we have our plus, so bringing that on down. And then y times t, we can just say yt without the parentheses. And this is the total area of our entire figure. And just looking down here, xz, that matches that. Like I said, xt or tx, that matches that. And notice it is getting subtracted, just like we have right here. And then we have plus ty or plus yt. It doesn't really matter the order there. So C is going to be our correct answer to that problem. Number 2, this may be a little bit too small, so let me rewrite this. We have xy cubed t, no, that's a z. So z to the 4th. And then in the other parentheses, x to the negative 4, y to the negative 3, and z to the negative 1. Now, a property of exponents, you'll learn about this in DMA 60, is if you're multiplying like bases, here's what I mean by like bases. That base is x, that base is x. Those are like bases. That base is y, that base is y. Those are like bases. That base is z, this base is z. Those are like bases. Whenever you multiply like bases, there's an understood multiplication here. All we really need to do with our exponents is add them. For example, this x right here, it does have an exponent. It's 1. X to the first is the same thing as just x. But when we add this exponent to this exponent, since we have like bases, notice x, x. 1 plus a negative 4 is going to be x to the negative 3. Let's do the same thing with our y's, our like bases here. So we got y to the 3rd times y to the negative 3. We add these two exponents, we get y to the 0. Do the same thing with your z's. So z to the 4th times z to the negative 1. 4 plus negative 1 equals z to the 3rd. Now, all these things are getting multiplied together, but you don't really need to put those dots there. And now let's work on each piece. Notice none of our answers have a negative exponent in it, so therefore we can say right here, x to the negative 3, a property of negative exponents is you can shoot this down to the bottom of your fraction. So I'm just going to write x to the positive 3. I'm just shooting it down to the bottom and I'm making that exponent positive. You don't really change the sign of the variable, only the exponent when you do that. Anything, any number to the 0 power is 1. So I could stick a 1 here, I could stick a 1 here, it doesn't really matter. Or you can just throw it away altogether because we have a z cubed which remains up top. I do have some other videos covering negative exponents, but that's the only thing I really did there is I shot this whole thing down to the bottom, made the exponent positive. That y to the 0 becomes 1, so you could put a 1 there if you want. There's nothing wrong with that. But that z cubed remains at the top of this fraction because there was no negative exponent. Now we're still not matching any of these. Well, here's another property. Notice both of these bases, even though they are different, they both have the same exponent. So what we could do here is we could say z over x, and since both of them are getting cubed, you can put it in parentheses and put a cubed on the outside of that fraction. That's the same thing as saying z cubed over x cubed. And that does match that answer right there, quite nice. Number 3, a over 2 minus b, and we want to square the whole thing. Right off the bat, you don't do this. You do not distribute the 2 into here and this is not right. You don't say a squared over 2 squared minus b squared. That is not how you handle this. And you'll hear more and more about this in your algebra classes where if you have 2 terms, if you have more than 1 term period, you cannot deal with the exponent like that. The correct way to deal with this, a over 2 minus b all squared is the same thing as a over 2 minus b times a over 2 minus b. And now maybe you've heard of something called the FOIL method. Though I'm not the biggest fan of it, it will help you multiply a binomial times a binomial. We have 2 terms here because they're separated by that minus. And we think of it as F for FOIL. We take the first term times the first term. First term in this parentheses, which is this, times this. Now you got to think, how do you multiply fractions? Top times top, so a times a is a squared. Bottom times bottom, so that's a squared over 4. That's the F because it's the first term, first term. Now do your outer terms. Think of this as being the inside or the middle. Your outer terms would be this one and this one. So we got to multiply these two together. A over 2 times negative B, we could put a 1 beneath that and do the same thing. Top times top, so we have minus AB, that's top times top, and then bottom times bottom, so 2 times 1 is 2. Alright, that's your O, that's called your outer. Now our inner, the two inside pieces will be these two. Notice, really, we're multiplying the exact same thing that we did right here in orange. Negative B times A over 2 is going to be the same thing as A over 2 times negative B. So it's the same exact thing. Top times top, I just wrote the A first, and then an understood 1, bottom times bottom, so 2. Alright, so first outer, that was our inner. Maybe I should keep my colors right, but that was pink earlier. And then last, so what's our last? The last term in each parentheses. For example, this is the last term in this parentheses, this is the last term in this parentheses. So let's multiply those together. And really don't worry about your fractions here, because 1 times 1 will give you 1. But what's a negative b times a negative b? Well, a negative times a negative is a positive. B times b, we say b squared. Now we have one more step to go here. The a squared over 4 remains because there's nothing else to combine with that. But if you look at these two pieces here, these are like terms. No, they do not cancel out. They would cancel out had this been a plus right here, because negative ab over 2 plus ab over 2, sure, that would cancel. But since we have negative ab over 2 minus another ab over 2, that's going to be minus 2 ab's over 2. And then we have our plus b squared. And now you may be looking for your answer to match up here, but look at this 2 over 2. We can cancel those out. So we actually do have one more step here. And our final answer will be a squared over 4 minus, we have just ab left. And the reason why is because this is like 2 times something, all divided by 2. Or we're multiplying by 2 at the top, we're multiplying by 2 at the, well, we're multiplying by 2 at the top, and we have a 2 at the bottom. There's no need to do that. They cancel out. And then we have plus b squared. So let's see what that matches up with. A squared over 4 minus ab plus b squared. Perfect. So C would be our choice right there. Number 4, x squared. If x squared minus 3x minus 18 equals 0, which of the following is possible for x? This is going to involve some factoring. So we're looking for, now I'm not going to dive into this real deep because, I have plenty of videos on factoring, but if you're familiar with factoring, you want to find two numbers whose product is this negative 18. And then you also want those same two numbers to have a sum, S, of negative 3. Now this takes a lot of practice if you've never done factoring before. Knowing why we need to do this, knowing when to do this, it does take practice. But nonetheless, this is what we want to do here. What's two numbers that multiply to give us negative 18? Well, that would be a negative 6 times 3. And if you add these two numbers together, negative 6 plus 3, that will also give you that sum there. Now you might have said, well, what about negative 9 times 2? Because negative 9 times 2 is 18. So you found two numbers that multiply to give you negative 18. However, when you add those two numbers, negative 9 plus 2, that equals negative 7. So, those two numbers did multiply to give us that, but they don't add to give us this here. So that's why we wouldn't want to pick that. And then you may think, well, what about 6 times negative 3? Well, 6 times negative 3 is 18, but if we take 6 plus a negative 3, that gives us a positive 3, and that doesn't match that sum that we need. That's why these two numbers here are the best numbers to have, or the only two numbers that we can have for this particular problem. Now, I encourage you to go check out my DMA. I got plenty of DMA 60 videos that pertain to factoring. And the shortcut here is this. And this is a easier factoring problem compared to some that you may see. But a little shortcut is if you find these two numbers for this particular problem, not all problems will be this quick. But those two numbers, you just put an X with them. And again, I cover this in more detail. But remember, our equation is equal to 0. I encourage you to do this. Pause the video and do the FOIL method again. FOIL this stuff out, you know, first, outer, inner, last, like I mentioned in the last video, and you will see that these two things multiplied together will give you exactly that. But we don't want to do that because we would just undo what we just did. The little shortcut here now is to say, okay, this times this has to be equal to 0. So one of these two pieces right here have to be 0. So set each factor is what these things are called. Set x minus 6 equal to 0, set x plus 3 equal to 0, and solve these equations real quick. I'm just adding 6 to both sides, so 6 is a possible answer. And to solve this equation over here, we just subtract 3 from both sides, so we get x equals negative 3. And looking at that, do we see a 6 or negative 3 up here? Sure, that one right there. Now, here's a little test taking tip. What you could have done too is you could have just plugged each one of these numbers in. And it says which of the following is a possible value. I mean, it is a solution to that equation, but depending on the type of problem you're doing, it might not be the solution that you want. But nonetheless, if we plug in 6 up here, let's plug in 6 and see what we get. What's 6 squared? That's 36. Minus 3 times 6, that's going to be 18. And then this minus 18 here as well. What does that give you? 36 minus 18 will give you 0. I assure you, if you check this one, and this one, they will not give you 0. Therefore, they are not possible solutions at all. That is a much faster way, but I'm telling you, you want to learn how to factor. So again, check out some of those videos on my website for factoring. Number 5, the function f of x equals negative x squared plus 40x minus 175 is graphed in the xy plane above. For what value of x is the value of f of x the greatest? Okay, f of x really means y. So where is y the tallest? Where's the graph the tallest? Where's the y value the biggest? Well, our y value here is 50, 100, 150, 200, 250, 300. Well, looking at this graph that you see right here, where is it the highest? It's not the highest here, it's not the highest here, it's not the highest here. It is the highest right about there. And that y value is somewhere between 200 and 250, so maybe like 225. But we don't want that to be our answer. We want to find what value of x gives us this maximum value up here. And that x value is what we're looking for right here. This x value of 20 will give us the absolute highest value for this particular quadratic graph. All right, that's it for number 5. Number 6. Now this is a factoring problem and a little bit of canceling out and stuff like that. But before we do this one, suppose we had something like 2 times 1 over 6, a DMA 20 topic. Now what we would probably do here to multiply these, I would put that over 1 just for explanation purposes, and the way you multiply fractions is top times top, so we have 2. 2 times 1 is 2, bottom times bottom. 1 times 6 is 6. Now, you might say, okay, yeah, I know this is 1/3, and it is. I mean, you can probably simplify that fraction in your head and say 1/3, but think about it like this. Isn't 2 over 6 the same thing as 2 over 2 times 3? 2 times 3 is the only thing I changed here, and that does give us that 6. And since we have common factors at the top and bottom, we can cancel those out, like you see right there. And notice this will give you the same answer as a understood 2 times 1, the 2 canceled out, so 2 times 1 is 2. We canceled the 2 out, so we're still left with that 1 up top. It's not a 0. 2 times 1 is still 2, but since we canceled the 2's out, we have to remember to keep that 1 up top. And then what's the only number we have left at the bottom? 3. As you can see, it matches that perfectly. And the reason why I'm saying this is because that's exactly how we want to approach this problem. So I'm going to put this over 1, and I'm going to say x plus 9 times 1 is x plus 9. I'll put it in parentheses just for the heck of it. Just like I did 2 times 1 is 2. Same idea. The bottom 1 times this junk is just that junk. So we have x squared plus 2x minus 63. Now we can't just go canceling out x's, and no, it don't work like that. You can't simplify the 9 into 63. Of course you can, but we can't do it right here. That is not the correct approach. What we want to do is think about it like this. I wrote that 6 as 2 times 3. What I did right there is I factored 6. So we want to factor this trinomial, this 3 terms that we see down here. And this works very similar to, how many problems ago was it? This one right here, like the product and the sum. It works very similar. We want to find two numbers that multiply to give us this, and we want those same two numbers to add to give us a positive 2. And you may be thinking, I got it. It's 9 times, or negative 9 times 7. Well, sure, that does give you negative 63. However, negative 9 plus 7 is equal to a negative 2. That does not match that sum that we want. So we didn't get it right there. However, we were so close, you know, negative 2 to positive 2. Let's switch the signs. Let's make the 9 positive and the 7 negative. That will still give you that negative 63. And if we take 9 plus a negative 7, that will give us that 2 that we want. So those are the pair of numbers whose product is negative 63 and whose sum is positive 2. So what we do here is we just go ahead and rewrite it out. X plus 9, I'm leaving that alone from what I had up top. You don't have to put it in parentheses, but I am anyway. And here's another one of those shortcuts. Once you find these two numbers, we write each one with the X. Since the 9 was positive, I put plus 9. Since the 7 was negative, I write X minus 7. And again, that's why I did this thing over here. The 2's canceled because they were common factors at the top and the bottom. The X plus 9's will cancel just like the 2's canceled. It works the exact same way. This is arithmetic, this is algebra. And you may say, okay, well, everything canceled. But still, there's an understood 1 times this stuff, so we have to make sure we include that in our answer. And then the only thing we have left at the bottom is X minus 7. So there's our answer, which matches this perfectly. But there you have it, 6 videos that pertain to the DMA 60 portion of the placement test. And again, factoring is a big deal in algebra. You want to make sure you can factor in your sleep by the time you get to your college algebra course and stuff like that, because it's just a small part to a big problem later on in future math classes. But again, for more videos on these topics, please visit this website here. And that's it for this video. Hope it helped.